Hello, welcome. This is a excuse me. This is a lesson on applications of quadratic functions, quadratic equations. The This diagram kind of points out some of the things that you might see in terms of what is called projectile motion. The y-intercept, where this crosses the y-axis, answers the question: how high off the ground did the object start? If it started at 0, it would be down here at the origin. But since it's up here, it would start at whatever value that is for y. So that's excuse me. The the y-intercept is the starting point. And then we've got the vertex, the highest point. The x value says when is the object at its maximum height? When is it at its highest point? And then the y value is the actual how high does that object get? Okay. And then you might see this question: how high is the object after blank seconds? So you plug in the given seconds into the graph's equation. And then let's see here. You've got two zeros or two x-intercepts. This 0 gets thrown out for being too negative. It's kind of tongue-in-cheek way of saying you can't have a negative time because the x-axis here is the time, and the y-axis is, we would say, f of t, or the height. So at the positive 0, when does the object hit the ground? That time t will give you how many seconds after it's thrown or dropped or launched or whatever it is. How long is the object in the air? Okay. The formula for projectile motion when an object goes up or down, the path is a parabola. It's a quadratic. The general form of that is the h of t is equal to negative 16 t squared plus vt plus c. And h of t is the height. The time is the variable t. V is the initial velocity, and that's in feet per second. C is the initial height. You sometimes see other variables, but we're using C to connect back to the general form of quadratic equation is y equals ax squared plus bx plus c. And then the initial height means the height when the time equals 0, right before you launch or drop or whatever it is that you're doing. The time is measured in seconds, and the height is measured in feet. Let's look at a first example. A firework is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The height of the hill is 80 feet, and the rocket is launched with an initial velocity of 64 feet per second. The rocket's height above the surface of the lake is given by this equation. H of t is equal to negative 16t squared plus 64t, again, that's the initial velocity, plus 80, and that's how high it was launched from. So it says sketch a graph of the function. All right, so we're going to write down here. We're going to write a vertical axis and a horizontal axis, and then we're going to graph kind of what this looks like. So it's a parabola, goes up like this and then back down. And then we're going to label just a few key points that we know here. This point right here is 80 feet. Maybe getting a little bit ahead of myself. Let's see, what does the horizontal axis represent? Well, the horizontal axis represents, as we've mentioned above, represents the time in seconds. And what does the vertical axis represent? Well, that's the height as a function of time, and that is in feet. And so we label them on the sketch, which we did. This right here we know is our starting point of 80 feet. And anything else on there we'd have to calculate. So we can come back and label those on the graph after we've done this. So what is the maximum height of the firework? Let's just make note here. I'm going to use this space here. We've got h of t is equal to negative 16 t squared plus 64t plus 80. Remember, the vertex, the x-coordinate of the vertex is negative b over 2a. And so b value is 64. We're going to write negative 64 over 2 times a, and a is negative 16. Sorry, over 2a, and a is negative 16. And so that's negative 64 over negative 32. The two negatives cancel each other out, and 64 divided by 32 is 2. Now, keep in mind that that's x, but in this example, it's actually t. That's the time. And so 2 represents 2 seconds. Then, to get the y-coordinate, we put that back in. H of t, in this case, we're going to h of 2. What is the height at 2 seconds? To find that, we just plug it in. Negative 16, instead of t, we've got 2 squared plus 64 times 2 plus 80. 2 squared is 4. 4 times negative 16 would be negative 64. Plus 64 times 2 is 128. And then plus 80. Negative 64 plus 128 would be a positive 64 plus 80. And 64 plus 80 would be 144. And once again, this is a height, and so this is 144 feet. So then we can go up here and we can label this, that point happens at 2 seconds, and it goes up to a height of 144 feet. All right, so what is the maximum height of the firework? 144 feet. And at what time is the firework at its highest point? At 2 seconds. All right, how long will it take for the firework to hit the lake? We know that it hits the lake right here when the height is 0. So they're launching it, if you will. I'll go over this here in red. Like, there's a hill here, right? So they're launching this firework off the lake, and it goes up, and then it comes down, and it hits the lake. And the lake, let's use a different color here. The lake right there is the point when the height equals 0. So what we do is we go to the equation, and instead of h of t, we're going to put 0. 0 equals negative 16 t squared plus 64t plus 80. And then to solve this, we have a number of different options. We could use the quadratic formula. We can try to factor. I think that in this case, these are all multiples of 16. So if I factor out negative 16 to make it our leading coefficient positive, that's negative 16 times t squared plus, that becomes, if I'm factoring out a negative, this becomes negative 4t, and then the plus 80, I factor that out, the negative 16, I get negative 5. And then we can factor this. We go to AC, and AC is negative 5 times 1, or negative 5, and B is negative 4. And so I'm looking for two numbers that multiply negative 5 that add to negative 4, and that would be positive 1 times a negative 5. 1 times negative 5 is negative 5. 1 plus negative 5 is negative 4. So my factors, I'm going to take this up here. 0 equals negative 16 times t plus 1 times t minus 5. And then I take, I can't set negative 16 equal to 0 because it's negative 16. But I can take t plus 1 and t minus 5 and set each of those equal to 0. T plus 1 equals 0 gives us a time that's equal to negative 1, because negative 1 plus 1 is 0. Or, on the other side, t minus 5 equals 0. And if I add 5 to both sides, then t equals 5. And as we mentioned above, the negative 0 we throw out because we don't have a negative time. So we can just discount the negative time. And so how long will it take for the firework to hit the lake? 5 seconds. So we can go up here and label that in our graph that this is at the point 5 seconds. It takes 5 seconds for the firework to go up and come down and hit the ground. All right. Let's look at the next example here. A rock is thrown upwards from the top of a 288-foot tall building with a velocity of 48 feet per second. Write a function for the distance in feet between the rock and the ground t seconds after it is thrown. The negative 16 t squared, same as the example above. That's not an accident. The initial velocity is 48, so we'll just put that in there. And the height is 288, so we put that in there. And that's our equation. Sketch a graph of the function. Okay, this is very similar to the last one. It's really going to be no difference there. This is going to be our height. This is going to be our time. It's going to start up here and go up for a certain distance and come down. And it doesn't matter if it's exactly accurate and represents what we see there. It's just a sketch. So it says mark the maximum height with a star. That's our maximum height. We're just going to put a star up there. And circle the point when it hits the ground. So we're just going to put a point right here and circle that because that's the point when it hits the ground. Also, I think it's worth noting that this point is 288. And then we can come back and mark in the other things. The 48 is how how fast it's going at the point that it's released. How long after the rock is thrown will it hit the ground? Okay. We need to go back here just like we did before. Instead of h of t, so let me just right here, h of t equals negative 16 t squared plus 48 t plus 288. But instead of h of t, we're going to put 0 because that's the height right here when it hits the ground. H of t equals 0. Remember, h of t is like y. The y value is 0. So just like we did in the last one, we're going to see maybe we can factor out 16 out of each of these. And yeah, if I take a negative 16 and I factor it out of the first term, that leaves a positive t squared. Negative 16 out of 48 leaves a negative 3, so that's negative 3t. And if I take 288 and divide it by negative 16, I get negative 18, so that's minus 18. And all of this is equal to 0. So then I can factor this again. Let's go up here. AC is negative 18, and B is negative 3. And I'm looking for two numbers that multiply to negative 18 and that add to negative 3, and I'm thinking that's going to be 3 and 6 with the negative on the 6. So 3 times negative 6, negative 18, and 3 plus negative 6 is negative 3. So my factors, negative 16 is equal to 0. The two factors are t plus 3 and t minus 6. Then set each of those factors equal to 0. The ones that can be 0, negative 16, again, we just sort of toss that out. But t plus 3 equals 0. If I subtract 3 and I subtract 3, that gives me t is equal to negative 3. Because it's negative, we don't have a negative time. The time is 0 or positive, but no negative time. So we'll just kind of toss that one out. And then on the other, so we say, or the t minus 6 equals 0. And here I'd add 6. And then t equals 6. And that's 6, like before, it's 6 seconds. And so our answer is 6 seconds. And then it says to label this on your sketch above. So we're going to go up here. This point right here is 6 seconds. Then it says, what is the maximum height of the rock? At what time is the rock at its highest point? Once again, we're going to go here to x equals negative b over 2a. B is 48, so that's negative of 48 over 2 times negative 16. And then we can write negative 48 divide by negative 2 times negative 16 be negative 32. And that gives us 1.5. Once again, that's seconds. Then it says, what is the maximum height of the rock? For that, we need to plug it in. So h of t, once again, the time here is 1.5. So I'm going to put that in there for t, is equal to negative 16 times 1.5 squared plus 48 times the time, 1.5, plus 288. And then this, I can just plug that into my calculator. So do that. Negative 16 times 1.5 squared plus 48 times 1.5 plus 288. When I hit enter, this comes back with 324. And once again, this is the height, so this is feet. So 1.5 and 324 feet. And then it says to label this on your sketch above. So we go back up here. And this point right here is at 1.5 seconds, and it's 324 feet. All right. What will the height of the rock be 3 seconds after it is thrown? We can find the height of the rock at any time after it's thrown by plugging it into the formula. So we'll just say the height at 3 seconds is equal to negative 16 times 3 squared plus 48 times 3 plus 288. Plug that into our calculator, we get negative 16 times 3 squared, remember to square it, plus 48 times 3, and then plus 288. And this comes back at 288. So once again, this is a height, and so it's 288 feet. All right. Last example here. In an effort to catch a criminal, a superhero is going to leap over a tall building and take a shortcut down the alley. The function f of x is equal to negative 16x squared plus 150x gives the superhero's height, f of x, in feet as a function of time. This time we're using x for time instead of t. The building is 425 feet high. Will the superhero make it over the building? Okay, let's make sure that we see what's going on here. Again, I think it's very useful to draw a sketch, even though we weren't specifically asked to do so. This time, instead of h of t, we'll write it as f of x, because f of x is the superhero's height. And x here is the time. Let's put this here. This is in seconds. And this over here, let's put this is in feet. And this time, the superhero jumps from the ground. And we know that because the standard form, f of x equals ax squared plus bx plus c, the y-intercept is 0, c. But this one doesn't have a constant term, which means that its constant term is 0. It would be the same as having here plus 0. And so the superhero is starting to jump from the ground. This is just different than the last examples that we've done. So he jumps up and he goes up and he comes back down. And what we want to know is his height at least 425 feet? We don't know yet. We're going to calculate it. So we need to know this maximum. So we're going to go once again to x equals negative b over 2a. B is negative 150. I'm sorry, b is 150, so it's the negative of that, negative 150, over 2 times a, and a is negative 16. And plug that in, do the calculation. We've got negative 150 divide by negative 32. And that gives us 4.6875 seconds, because we're looking for the x value. Once again, x is the time. To find the height, we need to take that value and plug it into the original formula. So we've got f of 4.6875 is equal to negative 16 times 4.6875 squared plus 150 times 4.6875. And when we plug that in, we get negative 16 times 4.6875. And we're squaring that first one, and then we go, plus 150 times 4.6875. And we hit enter. The height is 351. Let's go ahead and just kind of round that to 2 and make this is approximately 352 feet. So 352 is less than 425 feet. So this height right here is approximately 352 feet. That happens 4.5 seconds, 4.6875 seconds. But what we're really looking for is that maximum height. And the height of the building is 425 feet high. And so the answer is no. The superhero, we'll abbreviate that to hero. The hero will not make it over the building. 352 feet is less than 425 feet, so he's gonna hit that building. He's gonna smack into it. All right, that's it.